I'm so glad you found your way here tonight. Right now, as you settle in, your brain is carrying something you may not even realize. A question, a worry, a problem left unfinished at the edge of the day. But here is something science has only recently begun to fully understand. The moment you close your eyes, an old and quiet intelligence takes over. A part of you that never tires, never doubts, and never stops working. Your subconscious mind. Tonight, you will discover what that hidden mind is truly doing for you while you sleep, and why rest may be the most powerful form of problem-solving your brain ever performs. Welcome to Sleepy Science Facts. Wherever you are right now, perhaps lying in the quiet of your room, perhaps feeling the weight of the day still pressing gently behind your eyes, allow yourself to simply be here. We'll trace 100 science facts about the subconscious mind and sleep. From the very first electrical pulse that signals your brain to let go, to the deep chemical rivers that wash through your neurons as you dream, to the moment an answer arrives, fully formed, from the darkness of the night before, from the hidden language of brainwaves, to the landscape of REM sleep, to the silent intelligence that lives beneath your waking self. Breathe in slowly and let it go. Your subconscious has already begun its quiet work. You are safe. You are here. Let yourself rest now. What is your subconscious mind doing for you while you sleep? Scientists once believed the brain simply powered down at night, a passive rest between active days. We now know that picture was completely wrong. The sleeping brain is one of the most energetically active states the nervous system ever enters. During certain stages of sleep, the brain consumes nearly as much oxygen and glucose as it does during focused waking thought. Far from going quiet, it shifts into a different mode of operation, one built not for reacting to the world, but for reorganizing, consolidating, and working through the problems left open by the day. Sleep, in the deepest neurological sense, is where your mind does its most profound work. Your brain produces electrical waves that change character as you fall asleep, and each type of wave corresponds to a different state of inner experience. When you are alert and focused, your brain hums with fast beta waves, oscillating between roughly 13 and 30 cycles per second. As you relax and your eyes grow heavy, it slows into alpha waves, a rhythm tied to calm, creative readiness, around 8 to 12 cycles per second. As sleep deepens, theta waves emerge, slow, dreamy, around 4 to 8 cycles per second. These are the waves most closely linked to the twilight zone between wakefulness and sleep, the place where insights and unexpected connections tend to arise. Understanding these waves is like learning the language your subconscious speaks in silence. One of the central discoveries in modern sleep neuroscience is the glymphatic system, a network of channels surrounding the brain's blood vessels that functions as an internal waste clearance pathway. During waking hours, metabolic byproducts accumulate in the spaces between neurons. During sleep, especially deep, slow-wave sleep, cerebrospinal fluid surges through these channels in rhythmic pulses, flushing out proteins, including amyloid beta and tau, the same proteins linked to Alzheimer's disease. A 2025 clinical trial involving 39 participants directly confirmed that this clearance of amyloid beta and tau from the brain into the bloodstream happens during sleep in humans, not merely in animal models. Your sleep is, quite literally, a nightly cleanse of your thinking organ. The glymphatic system is most active during slow-wave sleep, the deepest, quietest phase of your sleep cycle. Research in animal models has identified that sleep-associated fluctuations in a brain chemical called norepinephrine drive vasomotion, the rhythmic contracting and relaxing of blood vessel walls, that propels cerebrospinal fluid through these clearance channels. This mechanism has been observed in rodents and is thought to operate similarly in humans, though direct human confirmation is still developing. It is a precisely orchestrated biological pump, synchronized with your brain's slowest and most restorative oscillations. When you shorten or fragment your sleep, this pump runs less efficiently. When you sleep well and deeply, it runs with full force, protecting your brain's long-term health with every slow, quiet hour. The subconscious mind processes information at a speed and scale the conscious mind cannot match. Neuroscientists estimate that the human nervous system receives roughly 11 million bits of information per second from the environment through all its sensory channels. The conscious mind can actively process only about 40 to 50 of those bits per second. Everything else, the vast ocean of sensory input, is handled invisibly, below awareness, by neural systems that filter, prioritize, and store information without your deliberate involvement. Sleep is the time when that ocean's contents get sorted and catalogued, and when the most useful pieces get surfaced. Every night, your brain replays the experiences of the day during a process called memory consolidation. During slow-wave sleep, the hippocampus, a curved, seahorse-shaped structure deep in the brain, reactivates the patterns of neural firing that were triggered by your waking experiences, and transfers stable versions of those memories into the cortex for long-term storage. This replay happens at a speed roughly 20 times faster than the original experience. Your brain is, in a very real sense, reviewing the day's footage on fast forward, deciding what to keep and where to file it. What you experienced consciously once, your subconscious processes many times over while you rest. Sleep stores memories, but it also transforms them. Researchers have found that after a night of sleep, people show improved ability to identify patterns and hidden rules within information they were exposed to the day before, even when they were not consciously aware that any such rules existed. The sleeping brain appears to strip memories down to their structural core, removing irrelevant surface details and retaining the underlying relationships. This is why you sometimes wake up understanding something you could not quite grasp the night before. Your subconscious was not just replaying the memory. It was editing it into something more useful. In a landmark study that has shaped decades of sleep research, scientists presented subjects with a complex mathematical task. The task contained a hidden shortcut, one that could reduce the number of steps needed. After a night of sleep, subjects were far more likely to discover that shortcut than those who had taken an equivalent period of waking rest. Those who slept were nearly 3 times more likely to find the insight. The researchers called this sleep-dependent insight formation. Sleep does not simply preserve the state of a problem. It restructures the problem itself, rearranging its elements in your neural landscape until a simpler, more elegant path becomes visible. REM, sleep, rapid eye movement sleep, is the stage most closely associated with dreaming, and it plays a uniquely valuable role in creative problem solving. During REM, the brain shows a pattern of activity that closely resembles waking cognition in some ways, but with a notable difference. The prefrontal cortex, the region responsible for logical, sequential, rule-governed thinking, is relatively quieter than during alert wakefulness. This means that during REM, the brain can make associations across distant, loosely related concepts that the waking mind would normally filter out as irrelevant. The very looseness of REM thinking is its particular strength. Scientists have identified a network of brain regions that together form what is called the default mode network, the DMN. This network activates when you are not focused on external tasks. When you daydream, reflect, mind wander, or rest. For a long time, the DMN was considered a kind of neural background hum, the brain idling between useful activities. We now understand that the DMN is far from idle. It is the brain's primary system for imaginative thinking, self-reflection, autobiographical memory, and generating creative insights. During sleep, and especially during the hypnagogic state just before and after sleep, the DMN is highly active, working on problems your conscious mind had set aside. In 2024, researchers provided the most direct causal evidence yet for the role of the default mode network in creative thinking. Using high-resolution electrode recordings placed inside the brains of human patients, the team was able to observe real-time DMN activity during both mind-wandering and creative thinking tasks. They found that gamma waves, high-frequency bursts associated with neural binding and insight, surged through the DMN when participants generated original ideas. The study provided the first direct, causal demonstration that the DMN is not merely correlated with creativity, it actively generates it. The same network most active during rest and sleep is the same one that produces your most original thoughts. The transition from wakefulness into sleep passes through a threshold called the hypnagogic state, a word derived from the Greek for leading into sleep. In this state, the brain is simultaneously generating the slow alpha and theta rhythms of relaxation while still holding fragments of conscious awareness. It is a state associated with vivid imagery, free associative thought, and sudden, unexpected insights. Many artists, inventors, and thinkers throughout history, including Thomas Edison, Salvador Dali, and Nikola Tesla, reportedly used deliberate techniques to prolong and harvest this state. Edison would nap holding steel balls in his hands. The moment he fell asleep, the balls would drop, waking him to capture whatever had just crossed his mind. In 2025, researchers published a study showing that the human brain does not gradually drift into sleep, it tips into it. Using detailed EEG monitoring and computational modeling, the team demonstrated that the transition from wakefulness to sleep occurs as an abrupt, threshold-crossing event, a neural tipping point. One moment, the brain is in a waking attractor state. Then, with a sudden shift in the balance of neural signals, it crosses a boundary and falls into sleep's attractor state. The moment of sleep onset is not a smooth fade but a discrete, predictable transition, one that scientists were, for the first time, able to predict with high accuracy. The subconscious mind has its own system of emotional processing that runs continuously beneath awareness. The amygdala, a small, almond-shaped structure in the brain's limbic system, responds to emotionally significant stimuli in as little as 14 milliseconds, far too fast for conscious thought to intercede. During sleep, particularly during REM, the amygdala remains highly active, replaying emotional memories in a context stripped of the stress hormone norepinephrine. Researchers have proposed that this is the brain's way of processing difficult experiences, replaying them enough times in a chemically calm state that the emotional charge gradually diminishes. Sleep, in this light, is a form of nightly emotional therapy. Scientists have shown that targeted memory reactivation during sleep can selectively strengthen specific memories. In these experiments, a sensory cue, such as a gentle sound or a soft odor, is associated with learning a particular skill or piece of information while awake. When that same cue is played quietly during slow-wave sleep, the brain reactivates the associated memory, consolidating it more deeply. This is not something the sleeping person is aware of. It happens entirely below conscious processing. The technique has successfully improved motor skill learning, vocabulary acquisition, and problem-solving involving hidden rules. The sleeping mind, it turns out, can be quietly directed. Your brain contains approximately 86 billion neurons. Each neuron can form connections, called synapses, with thousands of others. The total number of synaptic connections in the human brain is estimated at around 100 trillion. During waking hours, new synapses are formed constantly in response to experience. But forming too many connections leads to a problem. The brain becomes saturated with noise, and it becomes harder to pick out meaningful signals. Sleep appears to solve this through a process called synaptic homeostasis, a gentle, global downscaling of synaptic strength that happens during slow-wave sleep. While you rest, your brain quietly prunes and rebalances, removing the day's excess so the most valued connections stand out more clearly. Your sleeping brain does not only store and solve, it also communicates. Researchers have demonstrated that during sleep, the brain spontaneously replays sequences of neural activity that had occurred during problem-solving earlier in the day. In one study, participants who had learned a maze were shown to replay their maze-solving neural patterns during subsequent sleep, not just once, but multiple times, in compressed form. The hippocampus and the cortex appear to have a back-and-forth dialogue during this replay, the hippocampus generating rapid, detailed replays and the cortex gradually building a stable, abstracted understanding. The sleeping brain is a conversation between your short-term experiences and your long-term self. The pre-sleep period, roughly the 30 to 60 minutes before you fall asleep, is a time of unusual neurological openness. As the brain transitions from the focused beta wave activity of wakefulness toward the relaxed alpha waves of early drowsiness, it enters a state of heightened suggestibility and associative flexibility. Information encountered in this window has been shown in multiple studies to have a disproportionately strong influence on memory consolidation and on the content of subsequent dreaming. This is the biological basis of a very old piece of wisdom. What you dwell on before sleep shapes what your subconscious will work on through the night. The last thoughts before sleep are not just endings. They are instructions. Sleep deprivation does not only impair memory and attention. It specifically impairs the kind of flexible, associative thinking that underlies creativity and problem-solving. Studies comparing well-rested and sleep-deprived individuals on creative tasks consistently show that the sleep-deprived group performs significantly worse on problems requiring novel combinations of ideas, while performing relatively better on straightforward, step-by-step tasks. What is lost first when you are exhausted is not raw processing speed. It is the brain's ability to make unexpected leaps, to connect distant concepts, to hold two seemingly unrelated ideas together long enough to notice what they share. Sleep is the engine of creative intelligence. Dreaming appears to serve a specific function in problem-solving that is distinct from dreamless sleep. In recent research, scientists who deliberately provoked dreams of unsolved puzzles during REM sleep, using targeted memory reactivation applied while participants dreamed, found that subjects who dreamed about their problems were better at solving those problems upon waking than controls. The content of the dream mattered less than the fact of dreaming about the problem at all. It was as if the act of encounter, however strange and non-linear the dream form, was enough to prime the brain for insight upon waking. The dreaming mind does not solve in a straight line, but it solves. The sleeping brain shows patterns of activity across distant brain regions that almost never co-occur during focused waking thought. During REM sleep, brain imaging studies reveal synchronous activation of the visual cortex, the emotional limbic system, the memory centers of the hippocampus, and the associative areas of the frontal lobes, all at the same time. This cross-regional synchrony is thought to be the neural substrate of the dreaming experience, and also of the way sleep integrates knowledge from different domains. Problems that seem to belong to one category of thinking while you were awake may be quietly connected to solutions from a completely different domain by your dreaming brain. Your sleeping mind holds what psychologists call procedural memories. Memories for how to do things rather than what things are. Skills like riding a bicycle, typing, playing a chord on the guitar, the particular flick of a wrist in a tennis backhand. These are stored not as declarative facts, but as embedded motor programs in the cerebellum and basal ganglia. Sleep has been shown to consolidate procedural memories with striking specificity. Musicians who practice a difficult passage and then sleep are measurably better at it the next morning than those who practice and stay awake. The fingers, it seems, learn overnight, guided by a mind you cannot directly observe. What researchers call offline replay with modification is one of the more striking things the sleeping brain does. When the brain replays a memory or a learned pattern during sleep, it does not simply run an exact copy. It modifies the replay, slightly altering the sequence, applying new context, connecting it to related memories from different times and experiences. Over multiple nights of sleep, the same memory can be replayed and modified many times, gradually evolving from a specific episodic record into a generalized, flexible pattern. This is how the subconscious turns individual experiences into general wisdom. This is how you come, over years of sleeping and dreaming, to understand not just what happened, but what it means. The brain's capacity for insight, those moments where a solution arrives fully formed, appears to depend on a process called incubation. Incubation refers to a period during which you consciously stop working on a problem and allow the mind to rest. During this period, unconscious processing continues, free from the constraints and fixations that focused conscious thought had imposed on the problem. Sleep is the deepest and most effective form of incubation available to the human mind. The unconscious continues to explore the problem space, mapping analogies, removing irrelevant constraints, testing connections, without the interference of deliberate logic. When you wake, the insight is waiting. What is your subconscious mind doing for you while you sleep? The answer we are discovering is everything. It is cleaning your brain's physical structure, replaying and transforming your memories, processing your emotions, building your skills, and quietly working through every problem you brought to bed with you, solving and connecting without asking for your permission or your attention. You don't have to do anything. You never did. The most powerful problem solver you will ever know has been working for you every single night of your life. And it is working for you right now. You are already in its care. Let's pause here for just a moment. Breathe in slowly and release. Feel the places where your body is relaxed. Your hands, your shoulders, the space behind your eyes. Somewhere beneath your awareness, billions of neurons are already beginning their slow, unhurried work, replaying fragments of today, sorting what matters from what doesn't. Building bridges between ideas you haven't yet noticed are connected. You are already doing this. Without effort, without trying, you are already healing. Breathe out once more, and let yourself be heavy. The human sleep cycle repeats roughly 4 to 6 times each night. Each full cycle lasts approximately 90 to 110 minutes. Within each cycle, the brain moves through distinct stages. Light non-REM sleep in stages N1 and N2. Deep, slow-wave sleep in N3. And REM sleep. Early cycles contain more slow-wave sleep, which serves physical restoration and declarative memory consolidation. Later cycles shift toward progressively longer REM periods. This architecture is not arbitrary. The brain schedules different types of processing in a deliberate sequence, optimizing for both physical recovery and cognitive integration across the full span of your night. Slow-wave sleep, stage N-tray, is marked by large, synchronized brain oscillations called slow waves or delta waves, oscillating at less than 1 cycle per second. These waves represent a kind of mass synchrony of neural firing across wide regions of the cortex, a state that appears essential for the deepest forms of memory consolidation. During these waves, the hippocampus generates rapid bursts of activity called sharp wave ripples, while the thalamus produces sleep spindles, brief, rhythmic oscillations in the 12 to 14 Hz range. The coordination between these 3 structures, cortex, hippocampus, thalamus, is now believed to be the biological mechanism through which the day's experiences are durably encoded into the brain's long-term architecture. Sleep spindles, brief bursts of thalamic oscillation within deep sleep, are increasingly recognized as a marker of the brain's learning capacity. Research has shown that people who generate more sleep spindles during the night following a learning task tend to retain more of what they learned. Spindle density is positively correlated with verbal memory performance and the ability to integrate new information with existing knowledge. Sleep spindles appear to protect memories from interference by temporarily disconnecting the cortex from sensory input, creating an ideal internal environment for consolidation. In a very real sense, every sleep spindle is a small act of learning, conducted in silence. The sleeping brain appears to make sophisticated decisions about which memories to prioritize. Not all experiences are equally consolidated. The brain preferentially strengthens memories that are emotionally significant, connected to survival or social importance, and memories that are tagged as unfinished. Psychologists call this last category the Zeigarnik effect, the well-documented observation that incomplete tasks are better remembered than completed ones. The brain keeps incomplete problems in a kind of active buffer, continuing to work on them during sleep with more sustained effort than it devotes to resolved questions. Your unfinished problems are not abandoned at bedtime. They are moved to the front of the queue. The architecture of the brain during REM sleep has been described by neuroscientists as resembling a high-activity generator, a state where neural activation is high, but the patterns of activation are governed less by sensory input from the world and more by intrinsic, self-organized dynamics within the brain itself. This internal generativity is thought to create the conditions for what researchers call remote associations, connections between concepts stored in different brain regions that would rarely be activated simultaneously during waking focused thought. The dreaming brain is, in a structural sense, a machine designed to find connections the waking mind cannot see. Research into the default mode network across the human lifespan has found that the DMN undergoes significant developmental changes, particularly during childhood, adolescence, and again in later adulthood. In early life, the DMN's connections are diffuse and loosely organized. Through adolescence and early adulthood, they become increasingly refined and specialized. This maturation is closely tied to the development of abstract reasoning, empathy, and creative problem-solving capacity. The quality of sleep, and in particular the quantity and regularity of REM sleep, appears to be one of the key factors that drives this developmental refinement. Your brain's creative architecture was built, in part, by sleep. Your sleeping mind stores memories not as fixed recordings but as reconstructive patterns. When you remember something, you are not playing back a recording. You are reconstructing the experience in real time, assembling it from distributed fragments stored across multiple brain regions. This reconstructive nature of memory means that memories can change each time they are retrieved. During sleep, when the brain replays memories in modified forms, these modifications can become part of the stored version, meaning that sleep does not merely consolidate the past, it quietly edits it. What you remember tomorrow will be shaped, in subtle ways, by what your subconscious did with it tonight. Research into the role of sleep in emotional regulation has revealed a notable finding. When people are allowed to sleep after viewing emotionally difficult images, they show reduced amygdala response to those same images the following day, compared to people who remained awake. The brain does not simply replay difficult emotional memories during sleep. It processes them in a way that measurably reduces their emotional charge. This effect appears to depend on the presence of REM sleep. Studies that selectively limit REM while allowing other stages of sleep show a weaker version of this dampening. REM sleep, it appears, is where the heart has its chance to rest. The brain's subconscious problem-solving during sleep is not limited to abstract or creative challenges. Researchers have demonstrated sleep-facilitated improvement in practical motor problems, spatial navigation tasks, and mathematical reasoning. In one study, participants who slept after being given a social scenario involving moral complexity showed more nuanced and integrative moral reasoning the following day than those who stayed awake. The brain appears to use sleep to integrate competing values and perspectives, finding ways to hold complexity that the tired, linear waking mind struggles to maintain. Sleep does not only make the mind sharper, it makes the mind more whole. The hippocampus, your brain's primary memory hub, has a close relationship with the neocortex during sleep. During waking hours, the hippocampus acts as a rapid, temporary storage buffer, encoding new experiences quickly, but without long-term stability. During sleep, it engages in a coordinated dialogue with the neocortex, replaying those temporary memories and helping the cortex gradually build stable, long-term representations. This process, called systems consolidation, takes days, weeks, and even months to complete, but it is initiated and driven forward by the replays that occur during each night's sleep. Every night you sleep, you are tending to the architecture of your own understanding. Among the most well-confirmed findings about sleep and the subconscious is the research on language learning and vocabulary acquisition. Studies across multiple languages have shown that words and grammatical structures studied before sleep are retained significantly better than those studied during the morning, with consolidation occurring during both slow-wave and REM sleep. This is not merely reduced interference. The brain actively strengthens new linguistic representations during sleep, integrating them more deeply into existing semantic networks. Children, who sleep longer and with higher proportions of REM, learn language at rates that adults rarely match. And sleep is a meaningful part of the reason. Your sleeping brain carries out computations that would be difficult to replicate through deliberate, conscious effort. In mathematical insight studies, participants who were unable to solve problems requiring a hidden numerical rule after 30 minutes of deliberate effort were significantly more likely to find the solution after a full night's sleep, without any additional conscious work. More interestingly, many participants who solved the problem after sleep reported the solution simply appearing in their minds upon waking, without any sense of deliberate search. The solution had been found for them by the thinking they did not know they were doing. In the quiet of the night, scientists studying the relationship between sleep and creativity have proposed that REM sleep increases spreading activation in semantic memory networks. This is the tendency for activation of one memory node to spread along associative links to neighboring nodes. During waking focused thought, this spreading is constrained by the prefrontal cortex, which enforces relevance and logical coherence. During REM, those constraints relax, allowing activation to spread much farther across the semantic network, reaching concepts that would ordinarily be considered unrelated. This broader spreading activation is thought to be why creative insights so often feel like unexpected connections. The connection genuinely was not accessible before sleep made it possible. During sleep, the brain also processes sensory information that never reaches conscious awareness. Research has shown that sleeping humans can process and respond to their own name, to emotionally salient words, and even to simple logical relationships between spoken words, all without waking. The brain continues to monitor the environment through sensory gating mechanisms, maintaining a quiet readiness to wake if something significant demands attention. This vigilant system allowed our ancestors to sleep in uncertain environments and survive. Even in the deepest rest, a quiet part of you is still listening. The relationship between sleep and the subconscious was illustrated by studies examining what happens to people who are prevented from dreaming, specifically from entering REM sleep. Even when total sleep time was maintained and only REM was selectively limited, participants showed deterioration in emotional regulation, creative thinking, pattern recognition, and the ability to integrate information across different categories. They became more rigid and less able to see the connections between ideas. REM sleep is not an optional luxury. The brain indulges after the real work of slow-wave sleep is done. It is essential. The stage where the subconscious performs its most distinctive and irreplaceable functions. If you're still listening, still here with me in this quiet space between wakefulness and sleep, you might consider leaving a gentle like on this video. It tells this channel that there are people who need this kind of quiet, and it helps others find their way here too. Just a small, soft tap, and then back to the dark. The word subconscious, as used in everyday language, does not map perfectly onto the neuroscientist's vocabulary, but it points to something genuinely real. The vast proportion of brain processing that occurs outside the narrow beam of conscious attention. Neuroimaging studies consistently show that the brain initiates the neural activity leading to an action several hundred milliseconds before the person becomes consciously aware of deciding. The conscious experience of making a decision may, in many cases, be a report after the fact of a process already completed in the neural background. You are, in this very specific and measurable sense, a mind that knows more than it knows it knows. Intuition, the feeling of knowing something without knowing how you know it, appears to have a neural basis rooted in the brain's subconscious pattern recognition systems. Experienced professionals in many fields, chess players, emergency physicians, experienced firefighters, routinely make rapid, accurate decisions that outperform deliberate analytical reasoning under time pressure. Brain imaging studies of these expert intuitions reveal activation of the basal ganglia and the ventromedial prefrontal cortex, regions associated with implicit learning and value assessment. Sleep consolidates this implicit knowledge, gradually moving pattern-based expertise from slow, effortful cortical processing into faster, more automatic subcortical systems. Expertise, at its deepest level, is built across many nights of sleep. The brain's activity during the first minutes of sleep, stage N, ET, the shallowest phase, shows a notable property. It begins to generate hypnagogic imagery and thought that has a distinctly free associative, loosely narrative quality. Unlike waking thought, which tends toward logical structure and forward momentum, hypnagogic thought tends toward metaphor, condensation, and unexpected juxtaposition. Surreal images form and dissolve. The boundaries between self and environment soften. Researchers who have carefully studied this state suggest it may be one of the more creatively accessible moments in the full 2-4-hour cycle. A window of neural reorganization, particularly open to people who know how to rest without fully surrendering to sleep. One night of sleep deprivation causes measurable increases in the brain's emotional reactivity. Specifically, research has found a greater than 60% increase in amygdala response to negative stimuli, along with a weakening of the prefrontal cortex's regulatory influence over that response. After even one sleepless night, you are neurologically less equipped to regulate your emotional reactions. You become more vulnerable to threat-based thinking and less capable of the calm, integrative reasoning needed for complex problem-solving. The world does not become more threatening when you are sleep-deprived, but your brain becomes less able to accurately assess it. Sleep is the foundation of clear perception. Sleep does not only consolidate knowledge, it generalizes it too, extracting the underlying structure common to many different experiences and storing it as a transferable pattern. In one well-known study, participants learned a category task where items were sorted according to a hidden rule. Those who slept performed significantly better on novel items the following day, items they had never seen before, compared to those who stayed awake. The sleeping brain had extracted the rule and encoded it in a form that generalized beyond the specific training examples. Learning from experience, and being able to apply that learning to new situations, depends on sleep. Some of the most celebrated creative breakthroughs in scientific and artistic history have been attributed, in personal accounts, to the activity of the sleeping mind. The chemist Auguste Kekulé described discovering the ring structure of the benzene molecule after dreaming of a snake forming a circle, a visual metaphor that resolved a problem he had been working on for some time. The mathematician Srinivasa Ramanujan attributed many of his theorems to insights received in dreams. These are personal accounts and anecdotal impressions, not controlled scientific data, but they point, alongside the laboratory findings, toward a consistent picture. The dreaming mind sometimes reaches places the waking mind cannot. The brain's capacity for offline replay during sleep is not confined to the hippocampus. Research has shown that the motor cortex also replays recently learned movement sequences during sleep, with the timing of replay corresponding to periods of sleep spindles. The cerebellum, essential for fine motor coordination, shows its own pattern of consolidation-related activity during slow-wave sleep. This means that the improvement in physical skills that occurs after sleep is not simply a result of rest. It is the result of a kind of neural practice that happens entirely in the body's infrastructure, while you are completely still. Animals across the evolutionary tree, from simple invertebrates to complex mammals, show sleep-like states, including behavioral quiescence, reduced sensory responsiveness, and rebound after deprivation. Research in fruit flies, nematode worms, and even jellyfish-like organisms has identified sleep-like states with similar properties. This broad evolutionary conservation suggests that sleep solves a problem so fundamental to the existence of any nervous system that no species with neurons has been able to evolve past the need for it. Whatever the subconscious does during sleep, It is not a human luxury or a recent development. It is among the most ancient biological necessities in the history of life on this planet. The brain's chemical environment shifts considerably during different stages of sleep, and these shifts appear to be the very mechanisms through which different cognitive functions are carried out. Acetylcholine, a neurotransmitter involved in attention and memory encoding, surges during REM sleep to near waking levels. Serotonin and norepinephrine, involved in mood regulation and stress response, fall to lower levels during REM. This creates a calmer chemical context that allows emotional memories to be processed without reactivating a full stress response. Adenosine, which builds up during waking hours and drives sleep pressure, clears during sleep. The brain's nightly restoration is, in part, a chemical rebalancing, a resetting of the molecular conditions for clear thought. We return, here at the halfway point of our journey, to the question at the heart of this night. What is your subconscious mind doing for you while you sleep? The answer, we now see, is not a single thing, but a symphony of processes: chemical, electrical, structural, and connective, all working together to do what your conscious mind, for all its intelligence and effort, simply cannot do while it is busy being awake. Right now, as your breathing deepens, as your eyes grow heavier, as the day's urgency softens and retreats, the symphony is beginning. You don't have to conduct it. You only have to let it play. Take a deep, slow breath. Feel the air move in and out. You are halfway through the night's journey, and somewhere below the surface of your awareness, something is already shifting. A connection forming, a memory settling into place, a problem being quietly, patiently rearranged. Let your hands relax. Let your face relax. Let your breath find its own rhythm. You don't need to understand any of this. You don't need to remember any of this. Your mind already knows what to do. It has always known. The word insight has a specific technical meaning in cognitive neuroscience. It refers to the sudden, discontinuous arrival of a solution to a problem that had previously been blocked. Insight is distinct from gradual problem solving, where gradual solving feels like climbing steps. Insight feels like a floor that suddenly became solid beneath your feet. Brain imaging studies of insight moments show a characteristic burst of high-frequency gamma activity in the right anterior temporal lobe, a region associated with integration of distant, loosely related information. This burst happens approximately 300 milliseconds before the person consciously reports the insight. The brain knows before you know it knows. Sleep appears to shift the balance of the brain toward the very neural architecture that supports insight. Well-rested brains show increased baseline activity in the right hemisphere's temporal regions, the areas that show activity during insight moments. Sleep also increases what researchers call global workspace capacity, the brain's ability to simultaneously hold and integrate information from many different processing streams. This broader, more connected neural state is what allows insight to occur. The moment when a solution from one domain suddenly maps onto the structure of a problem in another. Rest does not merely recharge the brain. It reconfigures it. During REM sleep, the body is almost completely still. The brain stem sends inhibitory signals down the spinal cord that prevent the large muscles from acting on the movements and experiences of dreams. This paralysis is called REM atonia, and it is thought to be an evolutionary adaptation that prevents the dreaming animal from physically acting out dream behavior. The system is effective enough that the brain can generate the full vivid reality of running, flying, or solving complex problems, while the body remains completely still. The mind moves through entire worlds. The body waits, patient and quiet, for morning. The sleeping brain generates what researchers call memory reactivation events, brief moments when specific ensembles of neurons that fired together during waking experience are transiently reactivated during sleep. These events are associated with sleep spindles and sharp wave ripples, and last only fractions of a second. But their cumulative effect over hours of sleep is to gradually embed the pattern of those neurons' activity into the slower rhythms of the cortex, transferring a temporary hippocampal record into a more permanent cortical form. Each spindle, each ripple, each tiny reactivation is a small contribution to the permanent record of who you are and what you know. The relationship between sleep and the immune system is closer than most people realize. During sleep, the immune system undergoes active coordination. Cytokines, the chemical messengers that regulate immune response, are released at higher levels than during wakefulness. Slow-wave sleep appears to be a meaningful period for immunological memory consolidation, the process by which the body's immune cells become more efficient at recognizing pathogens or vaccine antigens. Studies have shown that people who sleep fewer than 7 hours are more susceptible to viral infection, and that immune response following vaccination is reduced in those who sleep poorly. Your sleep is part of your body's learning process. During sleep, the brain appears to have access to memories that conscious recall cannot readily reach. In experiments using indirect memory tests that measure the influence of a memory on behavior without requiring conscious recall, subjects show reliable evidence of learning for information they cannot consciously report having encoded. Sleep preferentially consolidates these implicit memories, the ones that live below the threshold of deliberate recollection. The body knows things the conscious mind cannot articulate. The hands know the route. The tongue knows the phrase. Sleep is where that knowing deepens and becomes durable. What scientists call sleep-dependent creative integration is one of the more intriguing things sleep does. The sleeping brain combines information from separate, previously independent learning episodes into a unified understanding. In one series of studies, participants learned 2 sets of information, A relating to B and B relating to C, but never explicitly learned that A related to C. After sleeping, participants were significantly better able to infer the indirect A to C relationship than those who had not slept. The sleeping brain had quietly built a bridge between 2 separate bodies of knowledge. This is how sleep creates understanding from information. Napping, even a brief rest of 20 to 30 minutes, can produce measurable improvements in alertness, working memory, and creative thinking. Longer naps of 60 to 90 minutes that include slow-wave sleep and the onset of REM provide more substantial cognitive restoration, including consolidation of memories formed in the preceding hours. Research in applied settings found that relatively short naps improved performance and alertness noticeably for pilots and operational personnel. The subconscious does not require the full night to begin its work. Even a small door opened into sleep is enough for the mind to step through and do something useful. The relationship between dreaming and problem-solving has been observed across cultures and throughout history. Ancient Greek healing centers, the Asclepians, were places where patients slept specifically to receive insight through dreams. Indigenous traditions around the world have long placed the dream state at the center of guidance and wisdom. In contemporary cognitive neuroscience, we are finding that these intuitions about the special quality of the dreaming mind were, in their own language, pointing at something real. The ancients did not understand the neuroscience, but they understood the experience. And the experience, it turns out, reflected a genuine biological truth. Saving what happened during the day is only part of what memory consolidation does during sleep. The brain also engages in schema integration, fitting new information into the existing frameworks of knowledge already stored in long-term memory. When new learning fits easily into an existing schema, consolidation is rapid and efficient. When new learning challenges an existing schema, the process is slower, requiring multiple nights of sleep and multiple rounds of replay to fully integrate. This is why learning something that genuinely changes your understanding takes time. Not because the information is difficult, but because the architecture has to be rebuilt. The sleeping brain, particularly during REM, shows elevated activity in a region called the anterior cingulate cortex, a structure involved in detecting conflicts, monitoring for inconsistencies, and evaluating competing options. This activity suggests that the dreaming brain is not simply replaying memories passively. It is actively evaluating them, flagging inconsistencies, and testing different resolutions. The dreaming mind appears to function as a quality monitoring system, identifying places where existing knowledge is incomplete or inadequate, and preparing the brain to update those representations. A recurring dream may signal precisely this, a concern the subconscious has not yet fully processed. Sleep consistently doubles or triples the rate of insight on problems that require a sudden restructuring of the problem representation, compared to equivalent waking rest. The benefit is specific to sleep. It is not simply the passage of time that matters, but what the brain does during that time. The offline processing of sleep creates the conditions for insight that the busy, focused waking mind cannot generate for itself, no matter how persistently it tries. The brain consolidates emotional memories differently from neutral ones. Emotional experiences trigger the release of hormones that strengthen the initial encoding of the memory, making emotionally charged events more vivid and more durable in the short term. During sleep, as these stress hormones fall, the brain replays emotional memories in a lower arousal context. Over successive nights, the factual content of an emotional memory is preserved, but the raw emotional charge gradually softens. Sleep is not forgetting. It is transforming what was once sharp and close into something that can, over time, be held more gently. The suprachiasmatic nucleus, a small cluster of roughly 20,000 neurons in the hypothalamus, is the brain's master clock. It receives direct input from light-sensitive cells in the retina. This input is used to synchronize the body's circadian rhythms, the approximately 2 4-hour biological cycles governing sleep timing, hormone release, and core body temperature. When circadian rhythms are disrupted by shift work, jet lag, or irregular sleep timing, the downstream effects on cognition, immunity, and mood are measurable and meaningful. This small structure generates time signals distributed to virtually every organ in the body. Your body runs on a clock. Your sleep guards its accuracy. The brain's capacity for future thinking, the ability to mentally simulate events that have not yet happened, depends heavily on the same neural systems that support memory, the hippocampus, and the default mode network. Imagination is memory reconfigured. The brain assembles simulations of possible futures by recombining elements drawn from past experience. And sleep is the time when those elements are most thoroughly reorganized and made available for new combinations. A well-rested brain imagines the future more flexibly than a depleted one. Sleep is the foundation not only of memory, but of the ability to envision what comes next. Researchers have found that dream content, while often non-linear and strange, reflects the brain's processing of emotionally significant, unresolved concerns. People anxious about an upcoming event tend to dream about scenarios related to that event, often in transformed, metaphorical forms. Athletes preparing for competition show more sport-related dream content. Students approaching examinations dream about studying. This is the subconscious mind doing what it does with every unsolved problem. Holding it, turning it over, testing different framings, until something becomes a little clearer. The strange language of dreams may be the closest we can observe to the subconscious at work. The sleeping brain continues to process language at a meaningful level. In experiments where participants were played sentences during sleep, some grammatically correct, some with subtle violations, EEG recordings showed different neural responses to correct versus incorrect sentences, indicating that grammatical processing continued even during sleep. During lighter stages of sleep, this processing was more robust. During deeper, slow-wave sleep, it became more selective, responding only to the most familiar and strongly conditioned linguistic patterns. Even in the depths of sleep, the language centers of the brain do not go completely quiet. The experience of sleeping on a problem and waking with greater clarity is documented in laboratory research and also in the accounts of people across many different fields. Writers describe waking with a resolved narrative problem. Scientists report waking with a design that had not been visible the night before. Engineers describe waking with a structural solution that arrived before they were fully conscious. These are personal impressions and anecdotal accounts, not controlled studies, but they align closely with the laboratory findings on sleep-dependent insight and offline replay. The subconscious does not advertise its work. It simply presents the result, quietly, in the early light. The brain undergoes measurable structural changes in response to learning. New synaptic connections form. Existing ones strengthen or weaken, and the local architecture of neural circuits is physically reorganized. These structural changes begin during the waking learning experience, but are consolidated and stabilized during sleep. Animal studies have shown that sleep after learning is associated with increased density of dendritic spines, the small protrusions on neurons where connections form, in cortical regions relevant to the learned task. While this has been most clearly demonstrated in animal models, converging evidence suggests a similar process occurs in human learning. In a literal, physical sense, sleep sculpts the brain. Recent research has explored using sleep to guide creative problem-solving through a technique called targeted memory reactivation. A specific sensory cue, a sound or smell, is paired with a problem while the person is awake. That same cue is then played softly during slow-wave sleep, prompting reactivation of the associated memory. Studies using this technique have found modest but consistent improvements in the post-sleep solving of cued problems compared to uncued controls. The technique is still early in its development, but it suggests an intriguing possibility: that we may one day be able to gently guide the subconscious mind's nocturnal work towards specific challenges. The quality of sleep, not just its duration, matters meaningfully for cognitive function. Fragmented sleep, in which normal progression through sleep stages is disrupted by frequent brief awakenings, is associated with reduced cognitive performance even when total sleep time is adequate. The brain's most restorative processes, particularly the coordination of slow waves, spindles, and sharp wave ripples that drive memory consolidation, depend on unbroken runs of continuous sleep. Each interruption resets or partially reverses consolidation progress. A shorter night of deep, unbroken sleep may deliver more restoration than a longer night of fragmented, disrupted rest. The brain's sleep pressure system, governed primarily by the buildup of a chemical called adenosine during waking hours, ensures that sleep is, under normal conditions, self-regulating. The longer you have been awake, the more adenosine accumulates, and the stronger the drive to sleep becomes. When you finally sleep, adenosine is cleared, and you wake feeling restored. Caffeine works by blocking adenosine receptors. It does not remove adenosine, merely masks its signal. This means caffeine-sustained wakefulness does not eliminate sleep pressure. It postpones it. The debt accumulates, and problem-solving capacity quietly diminishes with each additional hour of insufficiently cleared adenosine. There is no true substitute for sleep. Studies of the relationship between sleep and complex emotional intelligence, including empathy, social perception, and the ability to read the emotional states of others, consistently find that sleep deprivation impairs these capacities, while adequate sleep supports them. The sleeping brain appears to refine social perception during REM sleep, consolidating subtle patterns of facial expression and vocal tone that allow us to model the inner states of the people around us. Sleep makes us more attentive to each other, not as a matter of mood, but as a matter of perceptual accuracy. When we are rested, we simply see each other more clearly. The brain's default mode of operation, the state it returns to when not occupied with a specific external task, is a state of inward-directed processing tied to memory retrieval, future simulation, and reflective thought. This default mode is not a passive absence of activity. It is the brain's most natural operational mode, the one it has been using longest in evolutionary terms, the one it returns to most reliably when given freedom. Sleep, in many ways, is the full expression of this default mode. The brain freed entirely from the demands of the external world, turning inward to do the work that only silence allows. We are 3/4 of the way through our journey through the subconscious night. And by now, perhaps you feel it. A settling, a softening at the edges of thought, a willingness to stop holding things so tightly. This is not weakness. This is wisdom. What your subconscious mind does while you sleep, cleaning and healing your brain, weaving memories into understanding, solving the unresolved problems of your waking hours, is not something you have to earn or manage or control. You only have to allow it. Your sleeping mind is not resting. It is silently solving, healing, and rebuilding the very self you will wake up as. Breathe in and let go. Feel yourself growing heavier with each breath. The day is already gone. There is nothing left to hold on to, nothing left to solve tonight, with conscious effort. The part of you that knows how to rest is far older than the part that worries. Let the older part take over now. Let your thoughts drift like clouds across a dark sky. You are safe. You are still. Everything that needs to be worked on is already being worked on. The brain does not go silent in sleep. It murmurs. Beneath the threshold of awareness, patterns of activation ebb and flow through billions of neurons, moving in the slow, steady rhythm of the deep night. In this quiet murmuring, your experiences of the day are being folded into your history, and your history is being folded, softly and patiently, into yourself. Sleep researchers have found that people solve more anagram puzzles in the morning, after sleep, than in the evening, before sleep, even when the same amount of time has passed. Overnight, the brain reorganizes its language networks, and words that seemed fixed in unhelpful patterns the night before become fluid and rearrangeable. Morning is different from evening. The night has done something to the mind. The hippocampus, during the deepest hours of sleep, generates waves of electrical activity called sharp wave ripples. Brief, powerful bursts, lasting only about 100 milliseconds. Each ripple carries a compressed replay of a waking experience. Thousands of ripples occur each night. Thousands of memories, touched and released and touched again, until they find their final form. Like stones worn smooth by a river that never stops. The slow oscillations of deep sleep travel across the surface of the brain like gentle waves, beginning near the frontal lobe and moving backward through the cortex, then returning again. Each wave is a breath of the whole brain. Each breath consolidates something. Each breath clears something. The brain breathes in its own way, in its own rhythm, moving through the dark with a patience that belongs entirely to sleep. Creative professionals in many fields, writers, composers, engineers, scientists, have noted in their own accounts that their best ideas often arrive not during peak effort, but in the quieter periods following rest. This aligns with physiological evidence. The brain's associative networks, enriched by sleep, make connections that the focused waking mind simply could not reach. Rest is productive. Silence is generative. The pause between notes is part of the music. The body moves through waves of hormonal change during sleep, aligned with the sleep cycle. Growth hormone, involved in cellular repair and metabolic regulation, is released in its greatest quantities during the first deep, slow wave episodes. typically in the first third of the night. This is one reason that going to bed late is particularly costly for physical restoration. The body runs a repair sequence on a biological schedule. Sleep on time, and the sequence runs. Delay it, and the body waits. During REM sleep, the brain generates a continuous stream of narratives, the dreams. These narratives are not random noise. They are the brain's attempt to construct meaning from the information it is reorganizing, to build a story around the fragments it is working with, to test different resolutions, to explore alternate framings of what has not yet been fully understood. Not every dream resolves something, but the dreaming mind is always, in its own quiet and non-linear way, trying to. The concept of sleeping on a problem is not a metaphor. It describes a real biological process. When you bring a problem to bed with you, when you hold it gently in mind as you fall asleep, you are, in a measurable sense, giving your subconscious the instruction to work on it. The problem enters the reactivation queue. The sleeping brain turns it over in the quiet dark. And sometimes, in the morning, something has changed. Not always, but more often than if you had simply pushed harder. The brain's capacity for creativity does not exist in a single location. It emerges from the coordinated interaction of multiple networks. The default mode network for imagination and association, the executive control network for evaluation and refinement, the salience network for detecting what matters. Sleep strengthens the connections between these networks, making their collaboration more fluid and more effective. Creativity is not a fixed gift. It is a function of a brain that has been well maintained, and the primary form of that maintenance is sleep. Animals that face the most complex social environments, primates, cetaceans, elephants, tend to show the longest and most elaborate sleep patterns, including extended REM phases. This pattern suggests that complex social cognition, the ability to model other minds, remember relationships, and navigate intricate social structures, may be among the factors that drove the evolution of elaborate sleep architecture. Your capacity to understand and connect with other people, to feel empathy and build trust. These are things that sleep, over evolutionary time, helped shape. Research on complex decision-making shows that people who sleep between receiving information and making a multivariable decision make better choices than those who decide immediately. The subconscious mind, freed from the bottleneck of conscious processing, weighs more variables simultaneously. It integrates what cannot all be held at once by the waking self. This is the brain's quiet argument for patience, for the value of a night between the question and the answer. In the later hours of the night, the fourth and fifth sleep cycles, REM periods grow longer, sometimes lasting 30 to 45 minutes. These extended episodes are believed to be particularly relevant for emotional processing and for the most elaborate forms of creative dreaming. This is one reason that cutting sleep short in the morning has a noticeable effect on emotional resilience and creative thinking. The most creatively active hours of sleep occur at the end of the night. They belong to those who let themselves finish. The mind that falls asleep is not exactly the mind that wakes. Something changes. Not visibly at first, but measurably. Problems that had no visible solution reveal an edge by morning. Emotions that felt sharp and close feel slightly softer, slightly farther away. Ideas that felt disconnected find themselves sitting next to each other, waiting to be noticed. Sleep is a subtle transformation, quiet, patient, and ongoing. Every night, a slightly different version of you opens your eyes to the light. The brain's problem-solving during sleep is not only about creativity. The slow waves of deep sleep also drive a careful editing process, strengthening the most frequently used synaptic connections and gently reducing the least used ones. This constant pruning and prioritization makes the neural landscape progressively more efficient and more aligned with your most valued patterns of understanding. What you attend to, what you practice, what you return to. Sleep makes more durable. What you no longer need fades gently, over nights and weeks, into quiet. Studies of people who report vivid and memorable dreams consistently show higher levels of activity, the default mode network, both during dreaming and during waking. This suggests that the capacity for vivid dreaming and the capacity for rich, internally directed waking thought are expressions of the same underlying neural architecture. The person who dreams vividly is the same person who reflects at length, who imagines the future with detail. The dreaming mind and the imagining mind are not separate. They are the same mind, in different light. Research in animal models found that lateral sleeping positions were associated with more effective glymphatic flow than other postures. While this has not been fully confirmed in human studies, it contributes to the broader understanding that the biology of sleep extends to the physical body in ways still being mapped. Even the posture of the sleeping body may play some role in the processes that protect and restore the brain. Sleep is not merely a mental event. It is something the whole body participates in. The subconscious mind is not, in the end, a separate entity living beneath your awareness. It is you, the larger, older, more patient version of you that does not have to be in control to be doing valuable work. Every neuron that fires in the quiet dark of your sleeping brain is yours. Every memory replayed, every emotion processed, every synaptic connection tended is part of your unfolding story. The subconscious is not a stranger. It is the part of you that never stops caring for the rest. Large-scale research on sleep and cognitive health consistently confirms what smaller studies have suggested for years. Sleep quality is among the lifestyle factors most consistently associated with both cognitive performance and long-term brain health across the lifespan. Not diet alone, not exercise alone, not social engagement alone. Though all of these contribute, sleep, more than any other single factor, appears in the research as a reliable predictor of the brain's ability to remain clear, flexible, and resilient over decades. Protect your sleep, and you protect your mind. Dreams are, in a scientific sense, a form of internal simulation. The brain constructs a model of reality, complete with sensory texture, emotional tone, and social interaction, entirely from internal resources. The fact that the brain can generate such complete simulations from within speaks to the generative power of the system's underlying imagination and memory. When you dream, you are watching your own mind create a world, and the world it creates, however strange, is telling you something about what it is working on. As the body moves into the final hours of sleep, the transition back toward wakefulness is gradual. Sleep becomes lighter, dream imagery begins to blend with early fragments of consciousness. The hypnopompic state, the counterpart to the hypnagogic twilight of sleep onset, is another zone of unusual accessibility. When the night's subconscious processing is closest to the surface, the moment just before you fully wake is one of the most fertile in the entire daily cycle of the mind. You are here. Still here. That alone is something. In a world of noise and urgency and the constant demand to be doing more, you have given yourself the quiet. And in the quiet, meaningful work is happening. The brain you will carry into tomorrow is being gently rebuilt, in the dark, by the oldest and most faithful part of yourself. Every mammal, every bird, every reptile studied so far shows clear evidence of REM-like states. The evolutionary origins of REM sleep may extend back more than 300 million years, to the common ancestor of reptiles and mammals. You share this dreaming biology with creatures that lived when the continents were still joined. The dreaming mind is not a recent invention. It is ancient beyond telling. And every night you dream, you participate in something that has been running, unbroken, for longer than the mountains have existed. The final hours of sleep, as the body prepares to return to waking, are accompanied by a gradual rise in core body temperature, a slow pulse of cortisol activating the brain's alerting systems, and a natural shift toward lighter sleep stages. This awakening process, undisturbed by alarms, is associated with the clearest, most rested cognitive state. The brain that wakes on its own schedule carries with it the full benefit of the night's processing. Your natural wake time is not indulgence. It is your brain completing its work. Problem-solving during sleep requires one thing above all: the permission to stop solving consciously. The people who benefit most from sleep-dependent insight are those who can genuinely set down the problem before bed, who trust, however slightly, that the work will continue without them. The brain cannot do its deepest reorganization while the conscious mind is still pulling at the threads. Rest is the effort of trusting a process you cannot see, and surrendering to a system wiser than the part of you that prefers to stay in control. What is your subconscious mind doing for you while you sleep everything that needs to be done? Right now, your brain is rewriting the memories of today into something you can use tomorrow. It is clearing the metabolic debris of consciousness. It is replaying your unfinished problems in a space where new solutions are possible. It is holding your emotional experiences with a quietness the waking world rarely allows. Your sleeping mind is not resting. It is silently solving, healing, and rebuilding the very self you will wake up as. We have traveled far tonight. From the first electrical wave of sleep onset, to the glymphatic rivers that run beneath thought. From the quiet firings of hippocampal memory replays to the creative coordination of the dreaming cortex. From the cold science of insight formation to the warm, ancient mystery of the dreaming mind. We traced the subconscious across the span of a single night's sleep, watching it clean, connect, transform, and quietly rebuild. And perhaps, in some part of you that is still listening, something has settled. Some understanding that was not quite formed before this night is a little more solid now, a little more at rest. The subconscious mind reminds us that so much of what matters most in the human experience happens in the spaces between our deliberate efforts in the pauses, in the silences, in the dark. Much of the work of being a thinking, feeling creature happens without our knowledge, patiently, faithfully, in the hours when we have finally stopped trying, without sleep, without this ancient, irreplaceable process. The self we bring to each new day would be a little less whole, a little less clear, a little less capable of the understanding and the kindness that the world needs. By pausing to notice, we glimpse the gift of a mind that never stops caring for its own. Take one last slow breath. Feel the weight of your body, wholly supported. Let your thoughts dissolve, one by one, like stars at dawn, not gone, simply folded back into the light. Somewhere inside you, a conversation is continuing, neurons whispering to each other in the language of the night. You don't need to understand it. You don't need to direct it. You are already part of it. You are the night doing its work. You are the mind healing itself. You are the answer, forming in the dark. Let go of everything now. There is nothing left to hold. Only this. Only stillness. Only rest. If this thoughtful, quiet journey through the sleeping mind helped you relax tonight, a gentle like and subscribe helps other tired souls discover this peaceful place too. It only takes a moment, but it means everything to us. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, farther than most journeys take you. You can allow these thoughts of the sleeping mind to fade now, like thoughts themselves, just before sleep, leaving only the deep, wordless, quiet behind. Let your breathing deepen. Let your body feel heavier, as if the bed itself is the earth, holding you with the patience of something that has been holding sleeping creatures for a very long time. If sleep comes, let it carry you, smoothly, inevitably, into the realm where the subconscious continues its ancient, tireless work, where you are still thinking, still solving, still becoming, just not in any way you can observe. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the problems of the day will still be there. The world will still be waiting, but it will find you changed, in some small way, by what happened tonight, by the invisible work done in the quiet of this night. Rest well, curious mind. Fall asleep to gentle science, where curiosity meets rest. Dream deeper with bedtime facts. Good night.